Hello, everyone. Welcome to the world of data science. Now, I want you to imagine you are standing in the middle of a vast library. Not just any library, but that one that holds the entire knowledge of the universe. A library filled with knowledge about natural disasters, human and animal behaviors, galaxies, and everything that you can imagine. The catch, the books in this library are written in a language that you have never seen before, a language that you don't understand. Yet, the answers to every question that you have ever heard, the questions that you ever have are contained in this library. Now imagine being handed a magical decoder, a tool that can translate this unknown language into something that you can easily understand. Yes, you guessed it right. That tool is called data science. The world of data science begins with a simple realization that data is everywhere. Every text you send, every click you make, every beat of your heart generates data. However, raw data alone does not give us the full picture. This is where data scientists come in. They come in as puzzle solvers, as explorers, and as storytellers. They take this raw data and transform it into meaningful insights that can drive decisions and actions in businesses. This tutorial is designed to take you from zero to hero. By the end of this tutorial, you'll be able to understand what data science is. You will know how to harness its power and solve real-world problems. You will master the art of collecting, cleaning, and analyzing data, uncovering the patterns that others might miss. You will gain the skills to build predictive models, to create stunning visualizations, and extra insight that can transform industries and human lives. At the end of this course, we would have deep dived into Python and R, the two most powerful languages of data manipulation and analysis. Along the way, you also explore how to turn messy data into meaningful stories, the secrets behind machine learning. You also know how to create cutting edge models that power everything from recommendation engines to AI systems. But this course isn't just about learning tools, it's about developing that data scientist mindset, curiosity, creativity, and problem solving. These skills are the skills that will set you apart. Whether you dream of revolutionizing the healthcare, driving business decisions, or unlocking the mysteries of the universe, this course will equip you with everything you need to make data your superpower. So, let's embark on this journey together. Get ready to decode the universe, one data set at a time. Welcome again to the world of data science. Hello everyone. In this section of the tutorial, we're going to do a quick introduction to data science engineering, what it is, the career roles, the salary expectations, and also how to install the softwares necessary for this tutorial. So at its core, data science engineering borrows its concept from multiple fields such as computer science, machine learning, statistics, and also a little bit of business knowledge helps. But any skill, like I said before in other videos, that any skill that you might think of in IT is learnable. All you need is passion and drive. So it's an interdisciplinary field that borrows from multiple domains, and you can work as a data scientist, data analyst, data engineer after completing this course. The salary expectations are from 90,000 to 200,000 a year. Actually, most of the people that I know, they are within this range. But yes, I've seen crazy salaries such as 350,000, some up to 500,000. So it depends on the company. But from my experience, the majority of the people, they are within the 90,000 to $200,000 range. The tools that you would need to be an effective data scientist is Python and R. I'm going to show you how to install Jupyter Notebook and RStudio. SQL, standard query language to query data from databases. Tableau, Power BI. These are data visualization tools. I have a course already on introduction to Tableau that will take you from zero to hero, and another one on Power BI that is coming. Machine learning libraries and also cloud platforms such as AWS, Azure, and GCP. All right, so there's a life cycle that you, as a data scientist, will have to be familiar with when you're working in a real world. So you have to understand the business requirements. You have to prepare the data, be it by SQL, by some ETL processes. You have to develop the model or the algorithm that you need, or the solution that you will need. You need to test it to make sure that it's giving you the expected results, deploy it in production, and always support it. Supporting maybe making updates if there's any change in data, maybe you need to change something, but you have to support it. Then lastly, for this tutorial, we're going to focus primarily on R. programming and Python programming. So I'm going to show you how to install these two softwares, then you can get started. All right, so for R, we're going to use RStudio, and for Python, we are going to use Jupyter Notebook. And I'm going to share these two links in the description. All right, so on my browser right here, you for Jupyter Notebook, you can use Anaconda. You use Anaconda. So all you need is to put your email, agree, and submit. You're going to receive an email link. Go to that link, download it, the software, run it. It's gonna be an Anaconda Navigator. So I have it here, Anaconda Navigator, and it's gonna take a few minutes to load. And while it's loading, I am going to show you another way to do that. So if you go on jupyter.org, click it, you see this, this is the Anaconda, which is loading, but you see this Jupyter, and you can try it on your browser. Then you would want a Jupyter notebook. Either way, it works. And then you can create a new file. Right here, you can create a new code cell. Actually, I have a video that walks you through how to navigate the Jupyter notebook. Then this one is to save. It's a complete tutorial that can walk you through. So, all right, let's see if we can quickly open a new one, new notebook. Perfect. You can name it the way you want. All right, select. Perfect. So just for you to see, let's say print hello world. So this our Python hello world is running. So you can use the one on the web. I'll be using for the tutorial. I'll be using the Anaconda Navigator. This one. So once you run it, you are going to launch Jupyter Notebook, and it will give you the same interface. It will open on a browser, and it give you the same interface that I showed you earlier. There you go. So all you need is to run a new here, then the rest it will be the same as I showed you. All right, so the next software that you need is RStudio. So all you need to do is to go to post.co, download RStudio desktop. I'm going to share this link in the description below. If you're using Windows, you're going to do two steps. One, install the R, and after install R, you need to install RStudio. So I've already installed it. So here is RStudio, and this is the interface. And just to test it, y equals to 45. Print x. Perfect. So we're going to run this one, and y times x times y equals to this value. All right, so that's the software that you are going to need. Any software that you are going to need throughout the course, I'll be showing how to install it. But that's all that you need. See you on the next section of the tutorial. Hello, everyone. Welcome to this exciting section of the tutorial where we talk about mathematics for data science. Now, you do not have to be a genius, a math genius, for you to excel in data science. However, I would say that a good and solid understanding mathematical foundation is enough for you to understand the results, to manipulate the data, and also to interpret the results. So in this section, I'm going to talk about 8 concepts. First one is linear algebra, calculus, probability and statistics, numerical method, the graph theory, the Fourier transform, and dimensionality reduction. All right, we'll start with the basic linear algebra. Now, in data science, we will deal with matrices, 1D, 2D, 3D, 4D, 5D, all the way to whatever dimensions that you have. If you don't know what dimensions are, this is a dimension. That's how data is set up. And I have a video which explains NumPy in detail. and I show you how to manipulate dimensions. You can either add, multiply, transpose your dimensions. You may make your dimension flatter or taller, whatever it is that you want to do. But you would need to understand matrix operations. Why do we need to know linear algebra? Manipulating or performing matrix operations helps manage and process large data sets with many features such as like multiplication. Linear algebra techniques like matrix operation can be used to reduce the size of the image data, making it easier to analyze and to identify objects. So on linear algebra we also have what we call eigenvalues and eigenvectors. And let's jump to calculus. Now, calculus optimizes machine learning models by finding the best parameters like weights in a neural network. We'll come to this when we are actually using these principles, but this is just a general basic overview so that you can have a taste of what you're going into. Now, calculus is used to improve prediction accuracy and assessing the customer. Let's say I want to assess the customer's credit worth. Definitely, I would need to use calculus in evaluating the credit score. Probability and statistics. Yes, you want to know what is a mean, what is a variance. Mean is basically an average. So models, and you need to evaluate your model uncertainty, you evaluate the risk and you predict outcomes. So you need to understand this concept. Let's say in marketing, probability is used to predict how likely a customer is to buy a product based on their past behavior. So you have data and you measure your probability with a 90% probability, 98%, 95, 90%. You come to that when you're actually doing the hands-on projects. All right, numerical. Okay, let's quickly talk about distributions. We have normal distributions and varied distributions like these ones. Um, you need to understand what is a normal distribution, or what does it infer to the results. Okay, let's go to numerical methods. We would need numerical methods to solve mathematical operations that appear in any uh, machine learning model and to optimize our problems. Right. Let's say, for example, in finance, let's say we are doing a finance project. Numerical methods will help us optimize investment portfolios by balancing risks and returns. We'll use the PCA later in the course. Graph theory, it is used to analyze relationships or connections in data sets. It's more in a basic, example. Let's say we have an what you call it, just went out of my mind. But let's say we have a scatter plot. It kind of gives the relationships between two numerical values. So we would need a graph theory to analyze relationships or connections within data sets, like networks or any hierarchy that you might have. So let's say, for example, when you're working with a social media problem, a graph theory will identify influencers by analyzing connections between the user that they might have. Uh, Later in the projects, we are going to talk about the Fourier transform. We use the Fourier transform to identify patterns in time series data. Whenever we're dealing with time series data, always think of the Fourier transform, or signals, we're breaking them into frequencies. In a real world example, I'm thinking of a healthcare project where we can use this method to detect anomalies in heart rate or brainwave, uh, or to analyze the brainwave data from medical devices. Or let's say we're doing a cybersecurity project, we can use this Fourier transform to detect those anomalies. Actually, I have a project in my timeline where I do anomaly detection on cybersecurity. Just check it out and see how it's applied. Then logistic regression, we are going to use it. We have a project on this one. We'll explain that in detail. But yeah, I like actually a project in my timeline where we'll discuss about this. I used a logistic regression model for me to analyze sentiments on a YouTube comments. There's a project that I put out there in my timeline. And let's see if I have any. Oh, that's all that I have. But we're gonna have a hands-on exercises as we move into one by one. This is just a teaser for you to know what to expect and what we are going to do. And if you need to refine your knowledge in this in mathematics, you can just take one of the courses online and refine your skills over there. But again, you do not have to be an expert. Thank you for watching. See you in the next lecture of the course. Hello everyone, welcome to my SQL tutorial. All right, let's get started. For starters, I'm using pgadmin, which is an open source database, and I'm also using PostgreSQL. Now, SQL is it's an abbreviation for standard query language, a language that we use to extract data from database. It's a language that we use to code data from a database. All right, so I'm using pgadmin. If you want to see the table that you're working with, you go on schema, and on table, you expand that and you see all the tables that you have. All right. So to start, if you want to write comments, you use this double dash to write your comments. So in my case, I want to start with the basic SQL command to select all rows and columns from a table. So we use our select all from table. I will look at the table, let's say customer. All righty. So you can see I'm capitalizing my keywords here, and pgadmin is smart enough to use a different color for keywords. Select and all are keywords for pgadmin. So if I run it, it's going to return all the rows and all the columns in the table customer. Actually, you also need, it works either way, but you also need to use this kind of a semicolon as a standard language. All right, so I'm gonna comment this one. Actually, let me just, yeah, leave it like that. Comment it out, and let's do another one. Now, if you wanna select specific columns, you go again, select. Now we see we have customer ID, store ID, first name and last name. Let's say I just want first name, last name, and email. So here's how we do it. First name, last name, email from customer. Your kind of a semicolon, and you run it. So it will only return those three columns that you specify from the table. All right. I'm going to comment this one out. Then another one, I want to filter using the workflows. Select all customer where last name. Let's say I want to check maybe this last name. I would try to see maybe there's one or two that are called Smith here. And when I run it, it will only return uh, every row, every column for last name Smith. All right, let me fix this one. Let me do first name. Last name. I'll run it one more time. We have one person with the last name called Smith, but you use the workflows to filter your data. There's another one. Let me just delete this one for the sake of space. Let's do using and and or. All right. We select customer. Actually, let me do select off from payment first so that we can see what we have in this table called payment. So we see we have got payment ID, customer ID, staff ID, rental amount, and payment date. All right. So let's say select all from payment where customer three four one and amount is greater than or equal to 5. Let's see if we have any 341s where the amount here is greater than $5. Of course, we have one here, so we're gonna return at least one row of data. But lo and behold, we have a lots where customer ID is 341 and the amount is greater than 5. So you can use and the where clause that you can add another filtering option using the and. All right. Let's do some sorting. Again, select payment table. Order. Let's say you want to order by amount. Let's see what's going to happen here. All right, so it will, by default, if you just say order by, it will arrange from ascending to descending. So it will start from 0 all the way as we go up to 8, 9. But now order by amount, you can specify descending order. Then it will start with the highest amount in the amount column going to 0. So you can also specify ascending, but this will be the same as what we did earlier because this is the default way of sorting. Alrighty. Let's say you want to limit the number of results. Let me comment this one out. Select all from payment. Limit. Let's say we just want to see 10 rows of data. So it will limit only 10. And you can also do your filters, and then limit up to 10. All right, this is this. Let me take this one off. All right, there's this one called the having clause. All right, you have to select. Let's say I want to, let me go on customer name first. Select all from customer. All right, I just want to take a look at this table. All right, so select first name, last name, all right, these two. from customer, right? From customer table on a group by, I want to group by, let's say first name. Then you do our having clause here. Let me just do greater than 2 here. Let's see what we got from customer. Or let me make it simple at the moment. So to make it simple, what I did is I'm still using my customer. So select store ID. Remember we have, if I can do it back again. Select all from customer. All right. So we put multiple store IDs here. One, two. All right. So I'm in this example now. Let me take it off again since we have seen the table. Right. So select store ID, count customer IDs as customer counts from customer group by store ID. So basically, I'm looking at number of customer, count of customer IDs per store. Uh, Anything that have got store ID, customer IDs that's greater than 10. So that's your having clause here. And if I run it, let's see. All right. I have two store IDs which have got customer IDs which are greater than 10. All right. So since we are here, let me show you this one as renaming. I showed you renaming. So select first name as name from customer. So see, we had first name as a row, but I'm changing as a column name, but I'm changing it to names. So you use the as to rename your your um your column names. All right, let me see. So it changes, and if I do T, just to see how it's changing here. Whatever you want to write is going to change that column name to this column name. Then you can now use this one to filter, using your workflows to filter. Now, there's a lot that you can do with SQL, just like to do joining of tables. I'll show you in that my next video, but there's a lot that you can do with SQL. Basically, I use SQL to, in my Tableau, I use SQL to query data, then I use Tableau to manipulate that data. Thank you for watching. See you in the next video. Bye for now. Hello, everyone. I'm proud of your progress thus far. Welcome to this section where we talk about programming for data science. Now, this section is in two parts. The first part, we are going to talk about Python. The second part, we are going to talk about R programming. You need to have this skill dialed in for you to be a good data scientist. All right. Let's quickly jump into Python basics. Now, Python is a very user-friendly, beginner-friendly programming language. I actually have a video in my timeline which talks about, which actually introduces you Python from beginner to advanced. So if you go on my timeline, search introduction for Python, introduction to Python programming. I'll walk you through from the basics uh, to some advanced concepts. So if you go on my timeline, there's this video introductory to Python programming. That's all you need for you. You don't have to be a master in programming, but you have those basics dialed in. It will help you later in the course. All right, so we'll start with the basic print statement. Python, as I said, is very user friendly. So let's say I want to print a text here, like hello. Welcome to data science. So if I'm going to print it, it's going to show me welcome to data science. And if I add more cell here and say print, and I can print a number, print 32. And if I run it, it's going to print 32. Now, there's a lot that you can do with the print statement, but this is what we want for now. You can also ask the user input, then say, let's say you want to get inputs from the users. Then when you run this one, it's going to say enter your name. Then when they enter, like let's say Stanley Harris, then enter, then it will print Stanley Harris to the terminal. All right, that's basic print. There's a lot that you can do with the print statement, but for now, that's what we need. All right, let's do various data types. In Python, we deal with a wide number of data types. The first one is integer, like 32 that I gave you here, or a string, like hello, welcome to data science. We have an integer, which is a basic number with no commas. We have a float, like height 5.9, any number with a comma. Actually, we can do it this way. We can say size is equals to 3.5, print type of size. I want to see, that's another way for you to see what data type is size. So if I run it, it's going to tell me it's a float. All right, so string, I showed you a string. We can just say assign, this is a variable. These are variables. We call them variables. Then there's a convention that there are guidelines on how you name variables. But basically, there have been some. There have to be some. You have to start with a lowercase, and also it has to be specific to what you. It has to be intuitive. Like if you want a name, just say write it name, or skills, write it skills. All right. We have a list here. We have this square. If I can, yeah. We have this square brackets that's defined it as a list. If we use these curly brackets, that's how it's a dictionary. If we use for a tuple, you use this kind of brackets. All right. Um, let's quickly discuss about control structures. Now, these are very key, crucial. So you might need to understand this a little bit more. And let me do it this way. All right. So right now, I have for I in range 10. So let me just do for I in range 5. Let's see what we're gonna get. Let's say range 6, print I. There are guidelines on on when you are doing a, a control statement like this, you have to have a semicolon and you have to indent here. There are guidelines to that. Those all the basics are covered in that other tutorial. So range 6 is to print from 0 to 6. So we're going to see that from 0 to 5, 0 all the way to 5. So I can now do some manipulations. Let's say for I just represents any number, any numbers in the range 0 to 6. So I can literally say X here. It will still work the same. Then print X and print X. It will still work the same. So for X in the range from 0 all the way to 5. If x not 2 is equal to 0, print that x, and that x will be an even number, else print that x is an odd number. So if I run it, right, it will give me 2 is an even number, 4 is an even number, 5 and 3 are odd numbers. All right. There's a lot that you can do with the control flow. Dial them in. All right, let's quickly do functions. So functions, now we are introducing the concept of modular programming. Functions, they reduce your code into bits and pieces that you can use and call whenever you want to use them. So my basic function here. So when you are writing their guidelines, we have to use DE, define a function, name it, and use this brackets and semicolon. Let's say for my basic function, again, I want to do welcome. Now I have to leave 2 spaces and call my func again. So I'm gonna run it. It's gonna print welcome to data science. So now I don't have to type every time I need to type welcome to data science. I'll just call my func and it will print out whatever my func says. All right. So there's also another way to do your functions here, where you can assign a name. You can assign a default value to whatever you put in a function. So let's say, for example, if right now I'm saying greet Alice, it will print hi Alice, welcome to data science. But if I don't provide anything, it will just say NA, welcome to data science. Hi NA, welcome to data science. All right, that course we'll walk you through. All right, now the next section of the course, we are going to go deeper into Pandas, NumPy, Matplotlib, and Seaborn, and there are projects in there. And I would say we would need these four. These are the four main libraries that we need to use: NumPy, Pandas, Matplotlib, and Seaborn. And to use them, we just say import Pandas SPD. We would have imported them into our Jupyter notebook. All right, let's after the pandas and NumPy sections, we are going to jump into our programming. Thank you. See you on the other side of the lecture. Hello everyone, welcome to NumPy tutorial. In this video, we're going to discuss NumPy, what it is, and all the popular or most common functions or methods in NumPy. All right, so what is NumPy? NumPy is a Python library for working with numerical data. It is more beneficial if you're working with a large quantities of data. NumPy is more like a Python list, but it is more tuned to work with large quantities of data. It is mainly used in machine learning. It's also used in data science and scientific computing. All right. I would say NumPy is like Excel on steroids. It allows you to handle large, massive data sets with speed and efficiency. All right. It also allows you to optimize your memory, and also it has got many arrays or dimensions to data, and we are going to look at that. In this video, we're going to look at popular methods and also basic mathematical operations and broadcasting and I'm also using Python. All right. So right now I've already installed and I'm importing NumPy as NP. And our first example, we just gonna create a basic 1D array. All right. So I'll create a variable called ARR. np dot array. So here's the trick. That's the method array, and you just pass in your list. So 1, 2, 3, 4, 5. All right. So this is a 1D array. I'm going to print it. Just Python, kind of like a Python list. Let's create now a 2D array. So a 2D array is basically the same, but it have got two kind of lists, if you want to put it that way. So I will just take this one off. Now, for anything that is more than 1D array, it's called a matrix. So np.array. All right, so we are going to have two. So I will just do 1, 2. We are going to contain, then our first one will be 1 and 6. Then comma, second one. All right, let me just make it a little bit cleaner here. There you go. So I want to print my 2D matrix. There you go. All right, so you can go all the way to 3D, 4D. Let's just do another one. So this is a 3D one. All right. Perfect. Now, if you notice, I had less numbers in this one than the first two had 6 elements, and this had 5 elements. That's why it was throwing kind of a warning. All right, so you can go all the way to whatever the number of your D's here, dimensions rather. Okay, let's do array operations. I'll go back to my 1D array. Alrighty. Let's do a basic one. 1, 2, 3, 4, 5. Perfect. Print array plus 1. So every element in this array will be added 1 to 8. So let's see the results. So 1 plus 1 equals to 2. 2 plus 1 equals to 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1 equals 6. So you can actually also do, let's say, multiplication. Let me just do a bigger number here so that we can see what's going on. So every item in the array is multiplied by 10. So you can do all sorts of basic arithmetic with this one. You can also do power. You can also do right. You can do all sorts of operations with that one. Let's do matrix operation. This is for operation for 1D. So let's do a matrix operation. So matrix operations. Let's create our matrix here. Alrighty. So we have a simple one. 1 and 2. Then 3 and 4. 3 and 4. Perfect. I'm gonna print my matrix. So here's my 2D matrix and everything's fine. But now we want to do some let's transpose this matrix. So let's do matrix dot transpose and let's see what's going to happen here. So actually, if I do this, so this is the original 1, 2, 3, and 4. 1, 2, 3, and 4. Now, if I transpose it, it's going to be changed. So we'll be having 1, 3, 2, and 4. Actually, It was like horizontal, it's now vertical. 1 and 2, 3 and 4. All right, that's transposition for you. Um, you can also do some universal functions. All right, let's get started on universal functions. Let's say we have angles, np.array. Alrighty, 0, 30, 45, and 90 degrees, right? Then our radians is np dot the radians of these angles. Then print. Let's say I want to print the sine of angles. So we have np. We need to put radians here. All right. So let's run it. Then you have your sine of angles. So this is you using universal functions working with arrays. We call them U-functs. Let's move to another. Let's do slicing. Array slicing. We have our basic array here. Array. So we have, let's say 10, 20, 30, 40, 50. Perfect. So let's say I want to select this array and pull out specific elements. So array, just like we do string slicing and any other slicing in Python. Alrighty. So for this one, let me say 3. Yeah, 3. This will pull out the first 3 elements from this array. So if I run it, we had 10, 20, 30, 40, 50, but I started from everything from 0 to 3. So it will print 0. This is index position 0, 1, 2. Then 3, but it doesn't include 3 because we're including 0. So it will print 0 or 1, 2, 3. All right, so we can also do a reverse. Let's say we want to reverse this array. We do. Now, if you do not know indexing, find the topic on indexing in Python, and it will teach you the basics and how all these columns and negative one means. But you can do reverse. So it was starting from 0 to from 10 to 50. Now it's starting from 50 to 10. So that's how you do in slicing, like what you do string slicing or whatever slicing that you do in Python. Let's do random numbers. Let's say 3 and 3 here. All right, let's say print. So just print random numbers between this kind of a range. We can also do a random integers. Run ints np.random.randint. If you are not familiar with the random module, you can just import the random module, play around with it, and see what it does and all the methods that are in there. Alrighty. 2, let's say 3 here. Alright, ints. Let me see everything. Okay, yep. There you go. All right, so you can also do basic array. Let's do aggregations. So aggregations are your mean, your sum, your mean, your max. We have our array here, np.array. So we have 1, 2, 3, 4. Perfect. And we now do print sum array. Let's see what we got. So we are summing everything in all the elements. So the total will be 10. 3 plus 3 is 6 plus 4 equals to 10. We can also do min. np.min rather. Yes. We can also do max. We can also do min, which is a minimum. So you can do aggregations. Let's do broadcasting. All right, so we're gonna come up back again to our basic array. np.array, then 1, 2, 3. All right, perfect. And we want to broadcast our array. So let's say we have this with our array. Then we're gonna add another one. Let's say 10, 20, and 30. Perfect. So see what's going to happen. We have our array here, which is 1, 2, 3. We're going to broadcast it with this one, 10, 20, 30. So we are adding this 1 plus 10 equals to 11, 20 plus 2, 22, 33. Perfect. So that's how you do broadcasting. We can also do more advanced concepts like reshaping, flattening. I can show you. Let's quickly do that. So with our metrics, I'll say metrics 1 is equals to np dot array rather. Perfect. So we have our first one. I'll say 1 and 2. Then our second one, 3 and 4. Perfect. With our second one, I will just copy this one and change the numbers. Let me say 5 and 6. All right. So we've got two metrics, metrics 1 and metrics 2. All right. So here's what we want to do. Want to print np dot our initial metrics and the second matrix, which is number 2. All right. And also let's do final one. Wanna reshape it. So we have our metrics. Let me see if I still have it in memory. I'll just call it metrics is equals to perfect. So I put a 2D array right there. And I want to, let's do first print metrics. Let's see metrics. So it has to return the metrics as it is. Now, if I do metrics.reshape, then I specify how I want it to be shaped. So I would want maybe a 3x2. Let me see one more time. Okay, actually I might need to first specify because the sizing, I can just do this and let me do 10 here and that for here. Perfect. All right, because I was trying to shape a different into it was not set up to be able to be reshaped into a 3x2. So this was a 2x3. Now I've reshaped it to a 3x2. Alrighty, I can also flatten it. Perfect. So it was 2x3. Now it has been flattened and it's just like a 1D array here. All right, so recap. NumPy is a very powerful module in Python that we use for data science. Actually, it's your first step in data science. Play with it, be comfortable with it, because if you are going to be a data scientist, you're going to use it in many projects. So we use arrays to do mathematical operations, do slicing, we do broadcasting. Now, if you enjoyed this video, don't forget to like, subscribe, and share your questions in the comment section. Thank you, and bye-bye. See you in the next video. Hello, everyone. Welcome to the world of data science. Now, I want you to imagine you are standing in the middle of a vast library. Not just any library, but that one that holds the entire knowledge of the universe. A library filled with knowledge about natural disasters, human and animal behaviors, galaxies, and everything that you can imagine. The catch, the books in this library are written in a language that you have never seen before, a language that you don't understand. Yet, the answers to every question that you have ever heard, the questions that you ever have are contained in this library. Now imagine being handed a magical decoder, a tool that can translate this unknown language into something that you can easily understand. Yes, you guessed it right. That tool is called data science. The world of data science begins with a simple realization that data is everywhere. Every text you send, every click you make, every beat of your heart generates data. However, raw data alone does not give us the full picture. This is where data scientists come in. They come in as puzzle solvers, as explorers, and as storytellers. They take this raw data and transform it into meaningful insights that can drive decisions and actions in businesses. This tutorial is designed to take you from zero to hero. By the end of this tutorial, you'll be able to understand what data science is. You will know how to harness its power and solve real-world problems. You will master the art of collecting, cleaning, and analyzing data, uncovering the patterns that others might miss. You will gain the skills to build predictive models, to create stunning visualizations, and extra insight that can transform industries and human lives. At the end of this course, we would have deep dived into Python and R, the two most powerful languages of data manipulation and analysis. Along the way, you also explore how to turn messy data into meaningful stories, the secrets behind machine learning. You also know how to create cutting edge models that power everything from recommendation engines to AI systems. But this course isn't just about learning tools, it's about developing that data scientist mindset, curiosity, creativity, and problem solving. These skills are the skills that will set you apart. Whether you dream of revolutionizing the healthcare, driving business decisions, or unlocking the mysteries of the universe, this course will equip you with everything you need to make data your superpower. So, let's embark on this journey together. Get ready to decode the universe, one data set at a time. Welcome again to the world of data science. Hello, everyone. In this video, we are going to look at pandas. We always use pandas in data science, and we want to look at it and see any method that we might take away from it. So the first method that I want to share is dot head. So, so the dot head method shows you the first five rows of the data, but you can change the number of rows that you want to see. Let's say I want to see 10 rows. I just put 10 in there, and it will show me 0 to 9, which is 10. We start from index 0 all the way to 9. It just shows you the data that you have, and you can specify the number of the rows that you want to see. It's all up to you, and I'll just stick to the first five. The second one that I want to share with you is the .info method. So this the info method, it inspects and summarizes the data. Info. So it tells you that we have columns, participant ID, and comments. They are all objects, and they are all non-nouns, which means they're all filled in. In other words, you don't need to, if you see that there's a non-noun, you don't need to drop any empty columns, any empty rows. It will be all completed in. So that's the second one here. I'm going to comment it out, and let's go to the third one. So on this one, I'm going to share with you the describe method. Let's run it. So it shows us that the frequency of the data, the top, the uniqueness, are there 100% 100 unique data. So if there's any duplicates, you can take a look at this and use this information to inform your data analysis. All right, and let's go to the other one. We want to display the column names. Yeah, all right. It tells you the participant IDs and comments, they are all objects. Let's take a look to the other one. Now, this one that I'm trying to share right now is very good when you try to look at any missing values. So I have is now and some. When I can't find if they are now, let me put a comment right there. Mhm. All right. So I just use this now only without sum. It tells me that everyone is false. There's no now. Every file are all completed from 0 all the way to 100. All right. So there's another one that you use to drop any missing data. So it's df.drop now. Right. So the drop now method is used to drop rows with missing items in a row. We have nothing here, but you can use the drop now method to do that. You can also use another method. So to fill in, it's called fill now. So our df dot then your we have nothing here, so I don't really do anything. But we can use the fill method to be able to do that. But you have to specify now the column name. So let's say I have something. I've got some missing values in comments. Make sure I specified comments. The fill method. Then you want to say no comments. If there's no comments, right? We have nothing to replace, so nothing's going to happen. But that's how you do it. Then if there's any duplicates, you can use drop duplicates method. So it's df.drop underscore duplicates. We don't have any duplicates, so there's nothing really going to happen here. But I'm just going to show you this method. Then you can also do things like multi-line conditions, things like modify an existing column. Let's say it's uppercase, you want to drop it to lowercase or vice versa. You can use that method. You can also aggregate your data. You can group multiple columns. You can sort. Um, so those are some of the issues or some of the things that you can do with some of the methods that you can use when you import pandas and you want to manipulate your data. I will end here, but I will add all the other methods in the description below. Thank you for watching, and bye-bye for now. Hello everyone. In this video, we're going to show you how to install R in Jupyter Notebook. So right now you can see that I have an option to choose between a Python file and R file. So how do you do it? All right, all you need to do is to go to your start and open the Anaconda prompt. Then you have this terminal that opens and you are going to make changes on the base Anaconda files. So all you need to do is to type this code conda install c space dash c space r dash ir kernel. So once you install it, it's going to run. It's going to take a few seconds. Then there's an option to say yes or no. I've already done this, so I can actually do it right now. Let's see what it's going to tell me. It's going to take a time. Wait for it to finish. I had already installed, so there was no any installation. But basically, after you do your yes and install, it will give you this done status. After done status, all you need is to close your Anaconda, restart your Anaconda, and you have that option for R or a Python here. Thank you for watching. Bye for now. Hello everyone, welcome to this section of the tutorial where we do GBMs, gradient boosting machines. This is one of my favorites, so we're gonna just stay tuned and let's walk through the project. So we are going to use the Titanic dataset, and the goal there is to predict the survival of it on the Titanic using the GBM machine model. And before we get to the libraries and everything, let's explain what is gradient boosting machine and how does the model operate. Is of um, When you have a large data set, I would say first thing that you must think of if you are using a supervised learning machine, think of GBMs because it is very good in handling large amounts of data. It can also solve both the regression and classification problems. So what GBM does, it builds many models, which are basically decision trees, step by step. Each new tree tries to kind of to fix the mistakes made by the previous trees. So the model improves as more trees are added. So other models, GBM, instead of making one big model, GBM makes lots of small ones and combines them to get better results. Think of it as a sculptor. What that it does is chips one chip at a time, one tree at a time. Then at the end, it comes up with a very, very beautiful result. GBMs are used if you want to get high accuracy, flexibility, and also to handle missing data. But the downsides are it is very slow to train because it builds those many trees, and also if not tuned well, GBM will do a lot of overlifting. So you have to do your performance tuning before you trust your results. That being said, let's go quickly into my Jupyter notebook and let's get started. So we want to predict the survival of someone if he, depending on the factors or the features that we have. Alrighty. So let's go ahead and load the dataset. So to load the dataset, we just have to say data is equals to pd dot, it's a CSV file, read dot CSV, and push it everything here into copy into the brackets. And after that, all we want to do is to explore the data. So print data.head. Let's take a look and see what we have here. All right, let's see. Hey, crazy. Let's run one more time. Now I want to print again data.head. Perfect. All right, so these are the first five columns. So we've got passenger ID, survived, PC class. We have the name of the people who were on board. We have sex, the age, CIB, BSP. We have purchase ticket, fare, cabin, embarked. All right, perfect. All right, so now let's quickly do the info. Oh my goodness, what am I doing? Data.info. Perfect, perfect, perfect. So we have 11 columns, and now on and now. All right, let's do data.describe. So we have our mean, our standard deviation, max. Alrighty. Count, count, count. So looks like we'll take a look at it in detail. Looks like on age we might have some nulls in there, but we'll come to that later. All right. All right. So now let's see if we can visualize any missing data. So to do that, all we need to do is to use Seaborn. So data is now and there's nothing, then CMap. Missing values HMap. And also
Actually, all I need is to show here. Okay. Yes. So we can see that our age have got missing values and also cabin have missing values. So we might need to drop it or fill it. So let's see what's the best. Like I said, data cleaning is part and parcel of this career path. And sometimes you clean your data depending on the results. You need it's a set line motion. You look at the results, go back, clean the data back and forth. So it's part and parcel of this career path. Alrighty. So what I would want to do here, I would want to fill in. I would want to fill in the the missing values for age with the median and embarked with the mode. You choose what you want depending on the goal. I choose median mode here. So we're gonna do age and the data. So let's go ahead and continue to age. Now, these methods, I have a video which explains pandas in detail. So go ahead, take a look at that video and see what you can, or just go on documentation and and have a walkthrough on 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 pandas methods so that you can know what to use, when to use. With data, but I want it to fill with the mod. And right here, perfect. So we're gonna run this one, and let's drop. You see cabin right here. You've got too much, just too much missing values. So let's do another data cleaning here. So I want to use the drop method. And what we have is cabin. Alrighty. Actually, I don't need patch and ticket. Okay, I don't need ticket also. Let me take ticket out. Doesn't really help in this analysis. Axis is equals to when. Let's see one more time. So some of the columns that you don't need to keep it, because it will take time to process. It will cost you more. Let's say we have millions and millions of rows of data, so you don't want to overload on things that is not useful. So I want to do some conversions here. Conversions. So there, So I want male and female. So if you notice here, we had female, female, female. So I want to have a numerical number. We cannot really process strings here. So I'm changing male to 0, female to 1. You can change it the way you want it. I just did 0 and 1. Alrighty. Data is goes to PD get column. Alrighty. All I need is to run this and see. All right, perfect. And now features and target. So our X and our Y. And notice I'm capitalizing X and I'm also lowercasing Y. That's conversion and that's what we do. All right, for X, what I need to do is to specify those features. So data, all right. So if PC class, P class, these are just columns that are in the dataset that I'm using. Age, CIBSP, then we do fair. Yeah, I'll keep fair probably because of the fare that they paid probably to influence the seat they said. So embarked is perfect for Y. I want to see if they've survived or not. So we're gonna do survived. Effective. So let's run this and see what we got. Good. And let's go ahead. Split the data. The data. So to split the data, we have done this several times now. So X train, X train, X test. Then we have Y train, Y test is equals to train test split our X, which is X train, then Y, or Y, then test size. I still want to go with 80%, so my test size will be 0.2. Then random test, random state, keep it on 42 as usual. Alrighty, let's run this and see if it goes through no error. So we're gonna run this and perfect. Now, now our steps are now easier. Train the model. The good thing is we had been able to go through this together to see how each and every project is different. Gradient boosting classifier and I would say 0.1 max depth because they are all distant trees, so you have to specify. Otherwise, you come back again to the issue of overlifting. All right, model.fit. Let's quickly do it now. So our X train and Y train. Double check everything. And okay. All right. Discard. This is not the file that is being affected. So I have discarded that one. It doesn't really affect our project at hand. All right. So we have initialized our model. Let's go ahead, train the model, initialize it and everything. So let's go ahead and evaluate the model. So to evaluate the model, like I said earlier, model.predict x test. I'm moving a little bit fast now. Accuracy is equals to accuracy score y test y red, and let's print accuracy and check what we got. Accuracy 0.8% or 80%. Let's also go ahead and print classification report. So print a report for y test and y test and y classification report classification. Run it. Precision 0.8, accuracy 0.8, support record. All right. All righty. Let's do the confusion matrix. I'm going to use the heat map. I'll go with blues. And let's plot the heat map. Actually, let me do the title. Matrix and show. All right. Double check to make sure everything is looking as expected. Perfect. 010124 11. Perfect. All right. Let's just do a quick feature importance here. Want to see which feature is influences the results. So feature importance is equals to model dot feature importances plot dot figure, then specify the fixed size. Then also Seaborn, I want it to be a bar plot. You can, depending on what you want to, how you want to visualize it, you can visualize it differently than me. Perfect. Then I want the title. I just want to call it feature importances, and also just to show it out. Double check everything. And whilst I am here, let me add some columns so that it can be on top of my screen, not on the bottom of my screen. All right. So I'm going to run this one. Perfect. Oh, good. So it shows that sex had more impact or importance compared to the age, fair. Yeah, yeah, like as expected. The, the class which the person was seated at had also an impact as expected. Perfect. So, like I said earlier, we need to tune our model. Alrighty. So, so to tune our model, we need to do. I'm moving a little bit faster here. I won't be explaining a lot just because I want my video to be a little bit shorter. But you follow along. But at this point, you should be able to understand what's going on here. 0.2. And let's do max step. 3, 4, and 5. And let's just close this. I can increase the font size here. Perfect. And run this. And now what we want to do is to do continue with tuning. So to save time. And also I want to evaluate the best model. So to evaluate the best model, Pred best is equals to grid search best estimator predict. Now, as we move through these models, you can begin to see that there is no perfect model. There is nothing like a perfect model. You have to choose the best model that you think will work best for your use case. So there is no a magic model, magic test accuracy. It's all about finding the best model. Best accuracy. Why is it not? All right. Alrighty. So my improved accuracy is now 82%, 83%. Perfect. So now to test our model, test with new data set. I want to see if this person would have survived. So new data is equals to your appended data frame. Now, and also you begin to notice there would be other things that would affect the survivability of this person, of these people, other than just because of because of the data point that we have here. So again, machine learning models, they have their limitations. So use them with caution. Yes, they might give you somewhere closer, but it's things may turn out to be different. We have seen people who model things, and eventually they'll find out that the real world is a little bit different than what they would have modeled. So use this knowledge with considering all other factors. So I'm just adding age here of those people. You can add whatever age um these variables, they are typically up to you. 0 and 1 for fair. I'll go with 7.25 and 71.28. Now, this dynamic data set, we have used it in many data science projects, especially in Tableau. So we have added a new data set. We want to see how our model will predict. So new predictions is equals to predict just for it to be predictions needed to all we are doing is printing predictions. All right. So it says this if a person had all these attributes 3, 1, 25, 0, 0, 7.25, 0, and 1, they had a zero chance of survival. But if they had a PC class of 1, sex of a female, age of 38, all these attributes, they would have survived. So that's basically how we do GBMs, and we have to use this one for 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 the Titanic data set. All right, so basically that's all. Let's move on to the next model.